Welcome. This is a retake. I want to go over the Halix computer again and just look at the instructions that are available to you. The first two instructions are read and write. The effect of read is to take an input value and store it into the data memory. Write takes a data memory value and outputs it. Um, Now let's talk about instructions that you have. The primary unit for computation is the accumulator. So we need to ask how do you get values into the accumulator? And clearly the first way is to load, the load instruction. The other thing to note is that the accumulator always holds the result of a data manipulation. Whether it's arithmetic, the accumulator holds the result. Uh, Also, the accumulator holds the result of any kind of comparisons that you make. We're going to skip ahead a little bit. Instructions 18 through 23 are comparison instructions. They result in setting the accumulator to true, which will be a 1, or false, which is a 0. Other instructions affecting the accumulator are these instructions that involve constants. These instruction names end with the letter I, and we will see later on what I means, but it basically says this instruction contains a value that you're going to use. So I can say set I and equal sign 5, and basically it says put the value 5 into the accumulator. I can also add a constant to what's already in the accumulator or do any arithmetic with a constant that's already in the accumulator. The important thing is that the I instructions deal with constants. What else affects the accumulator? Um, there is an instruction that raises a value, a memory value, to some power. It's like the exponentiate or power function. Um, so that's the accumulator. Let's talk about data memory again. How is data memory impacted? So far, we changed data memory by storing, instruction 04. We change it by reading. What else do we do to change data memory? There's one special instruction called double, and it basically says whatever's in the data memory, double it. And those are the only instructions that impact or modify the data register. Now, there's also a register in the computer that we talked about called the instruction pointer. This is basically the address in the instruction memory where the next instruction will come from. And we saw earlier in class that with the instruction cycle, we fetch an instruction from the instruction memory, we place it into a register called the instruction register, and then we increment the instruction pointer, which simply says the next instruction will be one beyond the one where we are. And the value in the instruction pointer register determines what the next instruction is. Now, we've seen certain instructions like branch instructions. What does a branch instruction do? It alters where the next instruction comes from. So basically, we have all the branch instructions. You have to supply an address to branch to. And so the branch instructions basically change the IP on the fly. Okay? The last two instructions we have are B sub and return. We will talk about those in the coming week, and they have to do with subroutine or function calls. Now, with that, we're going to uh, end our discussion. One more thing. Uh, the accumulator can also be updated by uh, several instructions. One is clear, which sets it to 0, sets it to 1. Increment adds 1 to it, decrements, subtracts from it. And we said earlier the compare instructions will set it to true or false. So most programs that we write are really a dance between what's in data memory, what's in the accumulator, and the instructions that you employ. We will stop here with the instructions.